This is our first example on energy bar graphs. So we have a little toy here, and this thing in here is a spring. So there's a compressed spring, and you can see that we're at a height of 0. So because we're at a height of 0, there's no gravitational potential energy, but there is that spring that's deformed, and so there's elastic energy. Now how much elastic energy we choose is totally up to us. I'm going to pick 2 bars. Just seems like a good number to pick. The velocity of our chicken is not moving, so assuming that our velocity is 0, that means there's no kinetic energy. So that's it. Initially, there's only energy in the spring. Now, that's assuming that I pick my system as the spring and the toy. To me, they're one and the same. The spring is attached to the toy, so I can say the toy. And now, it's always safe to put Earth in your system in case there's any sort of gravitational potential energy that we're going to run into. So we've got our spring compressed for our elastic energy. Now in the final position we have obviously the chicken at some height above the ground. Now before I was measuring the height from the bottom of the toy, so I'm going to do the same thing and say that's the height. So if I was actually measuring a value, that's the height I would pick. But it's off the ground, and that's going to give us some gravitational potential energy. The spring is no longer stretched out or anything, so there's no elastic energy. And so now the question is their kinetic energy. It's not really clear from the picture, so let's assume that this is at the very top of the height, the highest it's going to go, so that velocity is 0, which means there's no kinetic energy. Now, assuming that it's moving through air and we had an object that was deformed, that means we're going to have lost some energy to friction or dissipated energy. So if energy is conserved, if I started out with 2 bars of energy over here, I need to end with 2 bars of energy over on our position B. So that means that between the gravitational and the dissipated energy, I need 2 bars. So I'm going to say it got 1 bar of EG and 1 bar of E-dis, so I'm showing that my energy is conserved. Now to make our conservation of energy statement, that's really easy. I'm just going to look at my left side, or my initial side, and list all the types of energy that we had. We had elastic energy. Then, because there's this dissipated energy, that was energy being taken out of your system, so that's going to be negative work done, and then it's going to equal all of the different types of energy that are over here on the second side. Well, there's only one type of energy. There's gravitational potential energy, so we have EG. And that would be it. That would be our conservation of energy equation and our bar graphs.